we can introduce you to an AutoML, a tool that is called PyCaret, which automates more or less, that modeling evaluation process. Then in the deployment, we're going to be using MLflow, okay, which is a tool that is open source, that you can do your modeling, your versioning, and your production environment using MLflow. But also we want you to get some knowledge on other tools, and we thought of maybe using Dash as a dashboard, Dash or Streamlit. Okay, now we can use that. So we're going to be fast-paced. So the next session is going to be in the next 2 weeks. Okay, and we're going to see if we can then gather some momentum and get those sessions every 2 weeks from now on. So we can then probably by September, October, we already have a model deployed. Okay, maybe in the cloud, or maybe in your local machine. Okay, so we're going to be a little bit fast-paced, because if you do it monthly, we probably will be to the next year. Okay, and we want to do other things. So is that clear? Any questions?
Yes, it's clear.
Okay, good. Okay, excellent. So let me stop the sharing here. Okay, let me give you that Discord channel link. Okay. Wait a minute. Here we go. That's the Discord channel. This link doesn't expire, so you should be, you should use it, whenever you can. Also, there is the Google Lab, right? The Google Drive link that we're going to use to then start up our notebook. Okay. Okay. So if you click to that drive, to that link, you're going to, you're going to go to the this place. Okay, let me show you. Okay, let me start sharing again my screen. Okay, can everyone see my screen?
Yes.
Yes.
Yeah, we're good.
Okay, so if you press that link, you should be arriving here. Okay, that's a folder in my drive. So the first thing that we're going to do, let me see if I can position my camera here. Let me see. Okay. Okay, so the first thing is that there's a couple of files there. I included the Launch and Learn PDF. There's one that it has the IPI description in the file. Okay, that's the notebook that we're going to be using. Another file of interest, okay, is going to be fraudtrain.csv. That is the data set. Okay, so the way that you are going to be starting that notebook is, if you follow my hand here, mouse, you see those three dots, in a vertical line. Just press it and then go to Open With. When you go to Open With, the first choice that is going to give you to open is Google Colaboratory. That's where you want to go. Okay, so when you press here, then you're going to open Google Colab. Okay, Jupyter Notebook. All right. Okay, so everyone following me so far?
Good to go.
Yes.
Okay, yes. All right. Okay, so let's give you a little bit of introduction to Google Lab. So Google Lab is really an environment, Jupyter Notebook environment in the cloud. Okay, so the first thing that you're going to do is at the right side, you see something called here Connect. Okay, and it gives you the alternate text that says click to connect. You're going to click that arrow, okay? Because it's going to give you options in terms of where do you want to connect this notebook to, what is called a runtime, right? And for simplicity, we're going to choose a connect to a hosted runtime. So it's going to create an environment, okay, in one of the cloud servers that is going to contain basically the most of the libraries that you use for data science in Python. It's going to include pandas, NumPy, matplotlib, even Seaborn is there, etc. So if you click connect to a hosted environment, hosted runtime, okay, it's going to give you it's going to allocate the resources, it's going to initialize, and then the final step is that you should have some indication of the RAM and the disk that is allocated to each to each session. Okay, so if you're successful, you're going to see this RAM and disk. Okay, we're good. We're good. Okay, so
On my side.
good. Everyone else? You got the session initiated and initialized? Good.
Yes.
Okay.
Yep.
Good. Okay. I'll text us, everyone is, going the same pace. All right. So let's read some of the information that we have in those notebook, which the notebook, one of the advantages of using it as an exploration tool is that you can mix code with text, okay? And the text is written in using the markdown, okay? So for example, the hashtags, they're going to have, they're going to have a meaning in the markdown in terms of the font size, etc. Okay. We're not going to go into too little detail, but if you want to know more information, just Google, markdown styles and all that, and give you more information. Okay. So this notebook, the objective of this notebook is to perform an exploratory data analysis. Okay. On the Kaggle credit fraud detection dataset and see source above, this is the link, okay, for that dataset. But you don't have to go there because it's already there. And I'll show you how to access it. Okay. Then there are multiple reasons to explore a data set. And usually is that you have to understand the data before building an ML model. In other words, you don't just, pour that data set, raw data into a model because you don't know exactly, what is it going to do. And probably it's going to give you, a couple of errors. So you have to, be able to understand the data in order to feed it properly to a machine learning algorithm. Then the other thing that you're going to be doing simultaneously is that you're going to be detecting some patterns about this data. For example, what is the composition? What is the data types? How many variables do I have? Are there any numeric variables? Are there any string variables, okay, that we can convert to categorical and so forth? Are there some dates there, type variables? So that's one of the things that you have to, research and investigate. And also to acquire some insights. Maybe for the stakeholder, it will be, wise, to inform him, okay, this is the data set that we collected, and this is the output the measure of quality that you have in that data set. Okay. So some of the steps that you should be, following in the exploratory data analysis. And the first step is not really, it has to do with coding. It really has to do with the documentation, okay, of the data set. For example, how was the data generated? If it was from a, database management system, or there are some external data set, that public data sets that you're using. In this case, this data set in particular is a simulated credit card transaction data set. So in other words, there was a program before that with certain parameters, it assembled this data set. So that is something that, maybe will help you in the insights that you're going to find. And the duration of the transactions is from January 1st, 2019 to December 2020, December 31st, 2020. So we have basically 2 years, okay, of credit card transactions. We have around 1,000 customers with a pool or a number of 800 merchants. All right. So read the documentation first, then we have to see what is the composition of the distribution or the labels of each of those columns or variables. If it is numeric, we'll go with the distribution. If it's a string or categorical, then we have to see, how many labels or how many categories that object data type has. Then, once we get a feeling of each of the, composition of each of the columns or variables, then we do some bivariate. Bivariate is when we combine two of those data types. Okay, so maybe you want to combine the target with some, predictor to see how well that predictor, categorizes your target in the case of classification. Then we go to multivariate. Multivariate, usually you use correlation, for example, multiple correlation. And also you use something called PCA, okay, principal component analysis. And then eventually you're going to have a conclusion and maybe some lessons learned on the whole cycle of exploratory data analysis. So for this session, we're going to be dealing more with the data types, right? And try to find out some of the characteristic of each of those variables, especially the target, okay, which is essential because the target is the one that is going to be, you're going to be predicting for, okay? So let's see, I'm going to put, to press this, is called import libraries. I already, wrote down the libraries that we're going to be using. We're going to be using pandas, NumPy, okay, the traditional ones. Matplotlib. Seaborn is a library that is like a wrapper for Matplotlib, because usually Matplotlib, you need, certain functions, certain commands to try to just, do a simple graph. So Seaborn is a wrapper for Matplotlib, and it gives you like a one-line code functions that you can then, with the parameters that the function needs, you can create the graphs that you require. Okay, we're going to filter the warnings. You know that usually when you run a command, pandas command or any command in Python, usually give you some warnings. So we're going to try to ignore those warnings, and then we're going to set the figures, the canvas figure of the plots to 20. Okay, that's the width, and the height 16. All right, so let's press this. Okay, and if you get a check mark here, okay, green check mark here, that means that all those functions run properly and you don't have any errors. Okay, so the first thing that you have to do is read the data set, right? The data set that we assemble. So what we're going to do here, right? I'm going to get rid of those comments. All right, so this one you have to follow me because you want to access the data set from your Google Drive, from the folder, that is attached to this notebook. The way that we're going to do it is, you see this menu to the left? All right, click where it says File, okay? Click here when it says Files. If you don't see a drive here, okay, and this is, that check mark is not it's not there, you have to mount the drive, okay, your Google Drive here. In my case, because I already did it, it's already mounted. All right, so you should see something called Drive, right? Then My Drive, and the folder that I created is called Kaggle Credit Fraud Detection. Okay, so if you go there, you'll see that file that I told you that the data set is in a CSV format, the fraud train. And what you're going to do here is, with those three dots in line, that's another menu. What you're going to do is copy that path. Okay, so maybe in your case, it's going to be a little bit different than mine. It all depends. But if you copy that path, what you have to do is copy the path and then paste it here inside the pd.read_CSV. Okay. Okay, inside those quotes. So we go here, okay, just one slash, and there you have it. You have the path within the Google Drive to access, that CSV file, which contains the information of the dataset. Okay, and if all goes well, when you hit the arrow, right, to run, okay, it's going to take some time because you'll see, you see the composition of this data set for the first time. Okay, so we have here, okay, I already read it to a file, a variable called df_raw, and then I repeated the df raw to give me, the first look of this data set. So one of the things that you can check is at the bottom is going to tell you how many rows and how many columns this data set has. It's a rectangular, it's a tabular data set, more like you can compare it like a spreadsheet. So it has 23 columns, in other words, 23 variables, okay, unique variables, and it has around 1,300,000 rows. So it's a fairly big, size data set. I just want to make sure that everyone is following me. Could you mount the drive and read the file?
So far, so good.
So far, so good? Okay, excellent. This is my first time, doing this, okay? Not the first time in Google Colab, but try to, get a group, okay, for following me in Google Drive, using Google Colab. Okay, excellent. All righty. So, okay, so let me ask you something. Do you see anything odd in this, first look of the data set? Does something strikes you like, that's weird? Everything looking good?
The only thing that
Uh-huh.
comes to mind at the moment is the variable size credit card number.
Ah, okay. That's interesting, right? What do you see? What do you say that it's odd?
I would expect that the all, if not the majority, in case there's some standard I'm unfamiliar with, but I would expect that the vast majority would have 16 characters in there, 16
Correct.
numbers rather.
Correct. I know one card that has only 15, American Express. Okay, but usually 16, you're right. Visa, MasterCard, they standardize the number of 16. So maybe what can you hypothesize, from that observation? Okay, Connor, right? Connor?
Yes.
Yes. What can you hypothesize then? What could be the explanation, the preliminary explanation, to that observation? Because it's a good observation.
I'm not too sure off the top of my head. One thing that I would try digging into is to see if there's any correlation between non-16 character length credit card numbers and a higher rate of fraud.
Right. No, yeah. Yeah, you're right. In fact, when we start exploring a little bit more, you see that CC number, is associated with a credit card, right? But it's not really the number of the credit card, okay? It contains a little more information about that, okay? But yeah, it's going to be useful for certain things, okay? Maybe not especially for, using it as it is, using it as a predictor, for the fraud target, but, it's going to be useful for something, okay? That we're going to cover that in the second session, okay? But good observation. Okay, one thing that you may notice is this column on name 0, okay? What do you think it is on name 0? Because it doesn't have a name associated with that column. That's why pandas, when it doesn't have a label, then it puts, something like that. What can you see about that on name 0? Is it similar to another column that you are, seeing here?
The numeric looks like a numerical index, just a count of the rows.
Exactly. Yeah. It's the same. It has the same values in the same order as the index. Okay. And the index is the first column. Okay. The 0 column, right? That's the index of your data set. So probably what happened is that when it was, created, when somebody save the file in a CSV format, they have to, use it. If they are using Python, they have to use something called index equal to false. In other words, not to repeat that column, okay? Because if you don't do that, then it's going to it's going to use the index as a column, all right? So one of the things that you can do, and this is a kind of a hack, right? Experience in the field, is that you can tell pandas, okay, the read CSV, to use that column as the index. Okay, so instead of having the index and that column duplicated those values, you can do from the read CSV, you can do index column and use that column, okay, the column 0. Okay, so let's see if we can get rid of this with that, with that instruction. It'll take some amount of time. Okay, so with the index equal to, the 0 column, which is the first that the read CSV is reading, you get rid of that. Okay, also you can get rid of it by dropping that column. Many ways of doing the same thing, but I found that, kind of, quick. Once I have that on name 0, which is the index of the previous of the file, I can get rid of it easily with that. Index column equal to bracket 0. All right. Okay, so let's see. What is this? Transaction day, transaction time. What do you think that is?
The date and time of the charge, the credit card charge.
Uh-huh. The date and time of the transaction, right? So it should
Right.
be, we expect the type because we cannot see the type here, right? We just see the label, right? The column name, but we don't see the type. So one thing that you should, have in your arsenal, okay, is right away check the data types of this data set or any data set. And you're going to do it with this function, info. Okay, data type info. So when you run that, okay, I have to reconnect. Sorry for the delay here. Yeah, it told me to reconnect. Okay. Yeah, probably could be the connection on my side. So if you can run this, okay, and you can tell me what do you see while I reconnect. Okay, here we go. What kind of types, data types do you see when you use df_raw.info?
I'm seeing a mixture of object, integer, floating point.
Mm-hmm.
Those are the three that I see in the list.
Right, you're going to see object, which are strings. You're going to see a float, okay, which means that numeric value has a decimal, right? Okay, it's not an integer. And then you're going to see integers too. Okay, let me see if it connects properly. I guess that the connection went down for some reason. Okay, let me see if I can join you right away. Hmm. Okay, here we go. But I have to run again the import. I have to run again the reading. Okay. Okay, let me run the info, right? All right. So Ron said that we have data types. That's the, rightmost column, D type. We have objects. Objects are, string type, but they also could include, like categorical, right? Variables. That depends on what kind of information we have there. Okay, if it's structured or not. Then we have float, which are numbers that have decimals. In other words, it has a continuous scale. And then we have integers, which are numbers without the decimal component. Okay, so what happened to that transaction day trans time? What type is?
Just an object.
It's an object, right? But we already know that that format is not really a string format, right? Okay, it's basically a date. So we have to change that object type so that we can have, the correct information and the correct interpretation. We need to convert it to a date. So this is another hack. Read that as underscore CSV has an argument that is called parse dates. Okay. So in parse dates, what you do is that you input in that argument, you input a list of the column names that you want pandas to translate to a datetime form. Okay. So if I put parse dates and trans date, trans time, cross your fingers, it's going to convert it to the right data type. Is there any other that you think that we should include that it should be interpreted as a date, another column? Which one?
Unix time.
Okay, Unix time. Let's see what Unix time is. I think Tom. How can I access the recording? We're going to post it in our channel, YouTube channel. Okay. We'll send a link. When it's posted, we send a link in Discord and also in the meetup chat. Okay. Okay, somebody said Unix time. Let's see Unix time. Okay, but Unix time has a real weird format here, right? Even though the label says it's a date, but it doesn't have the format of a date, right? So that's one thing that I will leave to you, okay, to check out. How can we convert that Unix time in that format to a date? Okay. But there's another one right before Unix time, which is DOB. Okay. It means date of birth. So date of birth, presumably, right, of the customer. So DOB also is a date. It doesn't have a time, right? But we can include it in that list. Okay. And you'll see that pandas, that function read underscore CSV is going to interpret the format of that string and convert it to a date format. So let's run this again. Okay, we have the index column to get rid of that additional index, and also trans date, trans time, and DOB. Let's see. Remember, Unix time, you have an assignment. To tell me in the second session, tell me how we can convert that to a date. Okay, so everything is similar, right? Everything is similar except that when we run again d_raw.info, we should see some changes. Okay, so now trans date, trans time is in the correct type, which is daytime, right? And also DOB is in the correct daytime, type. All right. So it's usually if you are spending time reading, try to make the most of it, right? So you can change some of the data types right there into a correct format, and also get rid of those additional indexes, okay? Okay, so can someone tell me which column or which variable is the target here? What is the name of the target?
Like it's column 21 is fraud.
Is fraud, yes, okay? And interesting is an integer, right? So in other words, let's see what fraud, brings us, okay? So let's see what is the composition of fraud. So let me do this here, okay? Okay, so because it's an integer, you can count it, right? So you can say, okay, how many are zeros? How many are one? Maybe there's a 2, there's a 3 there. Okay, so let's see. Let's count is fraud. Okay. So we're going to do this, df raw. Okay, we're going to select is fraud. And then we're going to use this function, value underscore counts. Okay, and let's run it. All right, so right off the bat, we see that is underscore fraud is just composed of two numbers, okay? One is 0, indicating that the transaction is not fraudulent, and 1, which indicates that it's fraudulent, okay? And that comes from the explanation of the data creator. But what can we see of the composition of the count between non-fraudulent transactions and fraudulent transactions? What can we see, right there? Are they balanced, or they go one way, instead of the other?
So there are significantly fewer fraud transactions.
Correct. Okay. In fact, you can get a feeling of the percentage, right, with value counts. And one of the arguments of what value counts is normalized. Okay, so if we see normalized equal true, instead of the count, the raw count, you are going to get a percentage, okay, or the decimal of the percentages. So if we do this, we see that almost 95.4% of the transactions are not fraudulent, and only 0.57 of the transactions are fraudulent. So we can make a comment here, okay, and that's the good thing about the Jupyter notebooks. We can say comment, okay, target is fraud, okay, is highly imbalanced. And why is this important? Well, in the machine learning algorithms, usually any algorithm expects the response variable, the ones that we are trying to predict. The algorithms, they expect the data to be kind of balanced, okay? So that, for example, if you are working a classification program that we do, the algorithm expects it to be balanced. Why? Because then it's going to give more weight to the majority class in detriment of the minority class. Okay, so we have to do certain manipulations to that target to make it a little bit more balanced. And we're going to see that when we go into the feature engineering and the machine learning modeling. Okay, but that's one thing that we have to recognize. Okay, if it's a classification, if the target is balanced or highly imbalanced. Okay. So looking again to the data type info, are there any others columns that you think they need to be changed? The data type need to be changed. Everything looks good so far? What about zip? Okay, which probably is the zip code, right? The zip code of the address, maybe of the transaction, or the place, that the customer, is the address of the customer. Okay, what to research that more. But zip here is an integer, right? Do we, do mathematical operations on zip codes? Usually?
We do not.
We do not, right? Okay, so zip codes, even though it says it's an integer because it's composed of integers, it's not, a number really. Okay, it's a label. Okay, it's a label for a place, for a location, spatial location. So we need to change that. Okay, we need to change that integer into an object. There's another one that we need to change, and it's one that it was also already mentioned, which is the CC underscore number. Okay, if it relates to a credit card number, etc., we don't do any mathematical operations with that. Okay, that's also a label. So the way that we do it, okay, is this way. df raw, right? Okay, and we're going to subset by the column that we want to change. And we're going to pipe it to as type. All right. And we're going to do the same for zip. Okay, so we're going to change both CC number and zip to a string. Or eventually it will become a categorical, but right now it's going to be an object. So let's do this. And we can go back here and check how our info, is progressing. Okay. So now we have CC number in the correct format object and zip in the correct format object. Okay, so remember, Unix time, you have to tell me next time, you have to tell me how to change using Python, using Pandas, etc., how to change that Unix time to a date. All right. Then, now that we have the data types more or less, correctly with their, with their column names. Another thing that you should do is verify if they are duplicates. Okay. Duplicate rows. In other words, if two or more rows have the same information. Okay. So the way that we do it is with this function, duplicate. Okay. Let me make sure that I'm doing the correct thing. Okay, it's duplicated. And then you're going to pipe it to sum because it's going to give you like a true or false indication. So true is 1 and false is 0, right? So if we do this, df row duplicated dot sum is going to give you, if there are duplicated rows, it's going to give you the total of the duplicated rows. Okay. So let's do this. Okay, and for fortune, our fortune, there's no duplicated rows. So let's do a comment. Okay, one of the things that, it's kind of a good practice is using the Jupyter notebook to document the progress of where you are, or the insights that you are gathering from the data set. Okay, so I can say in comment, no duplicated rows. Okay, exclamation point, good. Okay, let me see the chat. 5 minutes remaining. Yes, I'm aware of that. Okay. Then Another thing that we should be exploring is, like the duplicated rows, is if there are any missing values. Okay. So for that, we can use this function. Okay. It's null. Total them. Okay, but this one is going to give you each of the columns is going to tell you how many missing values have in each of the columns. And we want just the total. So we have to repeat that. We have to say, okay, give me the sum of each of the columns, but then give me the sum of the whole thing. Okay, of the whole series. So we go here. And by good fortune, there are no missing values. Something strange, because usually data is not perfect, right? There's always some issues, and usually you will encounter some missing values, but in here there are no missing values. Okay, so that's good. Okay, so for the numeric values, for the numeric columns, because we already had the objects, right? The data types correct, we can do some descriptive statistics, right? So in order to get some information about the numeric, columns, numeric variables, we can use something called describe. Okay, and I'm going to transpose the describe because it's easier that way, to read it. Okay, and we get from all these column names that are numeric types. It could be integers, it could be float. You get the counts, you get the average, the mean, you get the standard deviation, you get the minimum value, maximum value, and then the percentiles. First percentile, quarter percentiles, second quantiles, third quantile. Okay. And also, you can plot. You can plot it. Okay. So if we do this, this is a pandas function, which is, okay, from df raw, the ones that are numeric, give me the the histograms, okay, which is kind of a distribution of those numeric values, okay, which is easier to interpret than just numbers. So you go here. Right? And then you have an histogram or a distribution of all the numeric values, okay? It's already one, so right now we're going to stop here. Only one thing that I want you to explore. In that folder, there is another file, okay? There's another file. Let me see if I can get it here. Okay, there's another file that is an HTML file, an HTML report, okay? So when you can, let me see how I open it. Okay, I'll open it from my side. Okay. Let me see okay. So this is a report. Okay, we haven't gotten there yet. It's from a library called Pandas Profiling. So these reports give you a lot of the information that we're doing manually, okay, with some Pandas function. It will give it in one report. So when you can open it in a browser, okay, you're going to have an overview of more or less, what we have talked about, the number of columns, the number of observations, etc. Then each of the variables, the univariate analysis. Then you're going to have bivariate analysis, interactions, then correlations, missing values we don't have, and then some of the samples of the rows. All right. So for the next time, here are some of the questions that I want you to, to explore, to see more or less, what kind of answers you can generate. For example, In that report, you can see some correlations. So which of the variables are more correlated with the target? In other words, in the correlation part, there are going to be certain heat maps that are going to give you some information about how well that variable predicts the target, the isFRAD. So which are correlated and which are not. Then we have the Unix time field that we have to change to a date, and then try to compare it with the transaction date and time. See if there's repeat information or not. Then is the amount of transaction relevant to detect fraud? Okay, so maybe you have to do some visualization, etc. But I can help you there if you have any questions. What features can we extract from trans-date, trans-time? Because it's a date and it's a date transaction, we can extract certain features. For example, the month of the transaction, the day of the transaction, which number of the week was the transaction performed. If it was a Monday or a Wednesday or a Friday, etc. So think about it, which features and how you can extract some of the information from that date. And then what features have a high correlation and this feature redundant, all right? So what we're going to do is I'll see you in the next 2 weeks, okay? Probably will be Wednesday. I don't know if that's a good day for everyone, Wednesday. Okay, if everyone agrees, we're going to then set our next session, continue this exploration for the next 2 Wednesdays, okay? All right. So I think that's all the time we have left. Okay.